I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures. Just a quick one on chemical energetics, which is the first topic we're considering for A2. So for those of you coming back for A2, the first topic we'll be looking at is chemical energetics, where we'll talk about lattice energy. Now, when you hear the word lattice, it simply means the arrangement of atoms, molecules, or ions in a regular repeating pattern. We have the ionic lattice, which is the arrangement of positive and negatively charged ions in a regular repeating pattern. We have the metallic lattice, which is the arrangement of positive nuclei and C of the localized electrons in a regular repeating pattern. We have the simple molecular structure and giant covalent structure. We'll be looking at ionic lattice, which is the arrangement of oppositely charged ions, positive and negatively charged ions in a regular repeating pattern. When positively charged and negatively charged ions, when they come together, they form an ionic solid or ionic compound. So in that process, huge amount of energy is released because it has to do with the formation of an ionic compound. Huge amount of what energy is usually released because there's formation of what a compound. Now what happens is that what the amount of energy that is released when oppositely charged ions, positive and negatively charged ions, combine to form an ionic compound is what we call lattice energy. So in that process, huge amount of energy is released. So lattice energy is always exothermic. Lattice energy is always what? Exothermic. So we can define lattice energy as the enthalpy change when one mole of an ionic solid is formed from its gaseous ions under standard conditions. The enthalpy change when one mole of an ionic solid is formed from its gaseous ions under standard conditions. When we talk about standard conditions, we talk about temperature of what 298 Kelvin or 25 degrees Celsius, pressure of what 1 atmosphere or 100 kilopascal. If a solution is involved, the concentration will be 1 mole per dm3. So what are the factors affecting lattice energy? There are two major factors that affect lattice energy. We'll talk about the ionic charge, and the second one is what ionic size or ionic radius. Now let's see how ionic charge affects lattice energy. Now what happens is that what the higher the ionic charge, the more exothermic the lattice energy, the stronger the electrostatic force of attraction between the oppositely charged ion, the more stable the ionic compound, and the stronger the ionic bond. The lower the ionic charge or the smaller the ionic charge, the less exothermic the lattice energy, the weaker the electrostatic force of attraction between the oppositely charged ion, the less stable the ionic compound, and the weaker the ionic bond. That is for ionic charge. Then when we talk about ionic size or ionic radius, the smaller the ionic size or the smaller the ionic radius, the more exothermic the lattice energy, the greater the electrostatic force of attraction between the oppositely charged ion, the more stable the ionic compound, the stronger the ionic bond. Then the higher with the ionic size or ionic radius, or the larger the ionic size or ionic radius, the less exothermic the lattice energy, the weaker the electrostatic force of attraction between the oppositely charged ion, the less stable the ionic compound, and the weaker the ionic bond. So it's as simple as what? A, B, C. I'm Mr. Joseph, your chemistry teacher. Please subscribe to my YouTube channel, share, like, and reach out to me in case if you have any challenge or any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. I'll be posting the full video on lattice energy. So please, I want you to look out for the video. Thank you very much.